Welcome to today's Oracle Machine Learning Office Hours feature highlight session. Our topic today is exporting and importing Oracle Machine Learning models with Ethan Schmargad and Sherry LaMonica. I'm your host, Mark Hornick. In this session, Ethan will introduce us to the options for exporting and importing OML models, and Sherry will demonstrate the DBMS data mining package procedures that support export and import on both Oracle Database and Autonomous Database, as well as showing how to deploy a model to OML services using Postman. While OML allows you to build, evaluate, and deploy models in the same database, even the same schema, many enterprises separate development from production. So you can rebuild models in the production database, or you can export them for your production database, a common practice. Now further, you can export models specifically to OML services, which provides lightweight scoring using REST endpoints for real-time and streaming applications. Today, you'll learn all the ins and outs of how to export and import in-database models. Now before we begin, let's have a quick poll. What is your familiarity with in-database model export and import? Have you done this across Oracle database instances, autonomous database instances, or some combination of the two? Have you exported in-database models using the API for OML services? Or perhaps you've used the OML Models UI or the AutoML UI to deploy models to OML services. Perhaps you've exported models as a custom backup. Or you've never used these features, but are interested to learn how. Seems like we have a lot of folks who are new to model export and import, which is fantastic. So we're looking forward to sharing this with you, and others who have used this already in production systems and also have exported their in-database models to go with OML services or use the APIs. So we have a decent return on that as well. So thank you for sharing in our poll. And now over to you, Ethan and Sherry.
Thank you all for joining us today. So like Mark said, we will be looking into exporting and importing Oracle Machine Learning models. My name is Ethan Schmargad, and like Mark said, we'll be also joined by Sherry LaMonica. So to go into our agenda today, so we are going through the introduction, and then we're going to be going over the migration options for OML models, following that with some code examples and best practices. Then we'll be diving a little bit deeper into some architecture scenarios, followed by a demonstration that will be hosted by Sherry, and then finishing it off with a Q&A. So like I briefly introduced, my name is Ethan Schmargad. I'm a solution engineer here at Oracle, and I'll be covering the main portion of the deck today, and then Sherry LaMonica from the Oracle Machine Learning Product Management team will be taking over the demo. So let's jump right into it. Let's jump right into the options for exporting and importing OML models. So there are really several options available for migrating models between databases. So the first one is with the Oracle Data Pump, DBA or a user with export and import privileges can basically export and import a full database to and from a dump file. Or a regular database user can also export and import one or more schemas to and from a dump file if they are granted the Create Mining Model privilege. So in this situation, all of the database objects, including OML models, will be saved in the resulting dump file and can be restored in the target environment. The second option is the export model and import model procedures in the DBMS data mining package. And these can be used to export and import a single machine learning model, all machine learning models, or machine learning models that match a specific criteria. Export model and import model also support using a database link to export and import individual models to and from a remote database. The third option we have here is to work with a serialized model format. So in this situation, the export SIR model and import SIR model procedures in the DBMS data mining package were designed as kind of a lightweight approach to support scoring, which we'll explore in the coming slides. Export SIR model exports a single model to a serialized blob so that it can be imported and then scored in a separate OML database instance. And then import SIR model takes that serialized blob and creates the model in the target database. The serialized model format can also be deployed to OML services on Autonomous Database. So all three of these model migration options can be used with either Autonomous Database or Oracle Database on premises. And in the upcoming slides and demonstration, we'll show you these approaches and highlight some of the best practices for each. So now to go a little bit more in depth into the Data Pump utility. The Oracle Data Pump utility consists of the expdp and impdp commands. You can use either of these commands to export and import entire schemas or databases, like I briefly mentioned. The Data Pump export utility writes the schema objects, including the tables and OML model content, including the metadata, to a dump file set. And this Data Pump import utility retrieves those schema objects, including the model tables and the metadata, from the dump file and sets and restores them in the target database. In this scenario, all OML models are supported for import and export. It is best suited for when migrating a schema, multiple schemas, or moving to another database. So here's really an example of exporting a schema from a source environment to a target environment. The target schema can reside in the same database that is used for export or another database. As you can see on the left, OML user exports their schema to the data pump directory, but any directory that is defined as a directory in SQL by the user and accessible to the user will be completely fine and will work. And on the right, we can see that the dump file is saved to the data pump directory in the target environment by the target user OML user2 and imported. Notice here that the dump file name is expanded during export from schema.dmp to schema01.dmp. The number of files in the dump set is determined by the size of objects being exported, with a maximum file size of around 2 gigabytes. And the size of the exported object is greater than the maximum file size, additional files are simply created. The maximum file size can be specified by the user in the optional file size parameter, and any additional files are named sequentially as file02.dmp, file03.dmp, and so on and so forth. So now when importing the model, you may need to remap the schema and table space to match the target user's environment. And this can be necessary if the target user's schema name and table space is different than the source user. Here, we remap the schema from OML user to OML user2, and the table space from users to users2. However, with Autonomous Database, the user table space name is always data. And with Oracle Database, the user table space name is typically users, but can be customized. So note here that the expdp and impdp cannot be used to export import individual models. So, assuming we want to only migrate our models to another schema or database, what are the other options here? So now to go into the second option here, which is the DBMS data mining package. The export and import model procedures are part of the OML for SQL DBMS data mining package and are based on the Oracle Data Pump technologies. However, instead of migrating an entire schema or database, they can be used to import a specific model, list of models, or models that match a specific criteria, such as an algorithm or a specific mining function. In this case, export model exports a model or group of models to a dump file so that it can then be imported in a separate OML database instance. Import model takes the model dump file and then creates the model in the target database. And as a result of building models, each model has its own representation and a set of model detail views that provide information about the model, such as model statistics for evaluation. And these users can query these model detail views, and the views are different for each algorithm. It's important to note. So for example, for classification models, there is a view that describes the scoring cost matrix and another that describes the target distribution for classification models. Export model preserves the full detail views so the user can actually query them after being imported into the target database. So in turn, it is best suited in situations where the full model details are desired for model exploration, and when the target database is the same version or newer than the source database. Also note that in this scenario, all OML models are supported for import and export. So now to go into an example, here we have an example of exporting a single model, in this case called DT model, from a source environment to a target environment. The target schema can reside in the same database that is used for the export or another database. So on the left, you can see that OML user exports the model to the data pump directory. And like we briefly said in the previous example, any directory that is defined as a directory in SQL by the user and accessible to the user will work. And the model name then is then expanded to file name 01.dmp as it did with the traditional data pump export. And now if we point our attention to the right, the model dump file is saved to the data pump directory in the target environment by the target user, OML user2, and then imported. The schema and table space are remapped to match the target user's environment. So both export model and import model have a model filter parameter to specify individual or multiple models. And if you do not specify a value for model filter, all models in the schema are then exported. So we have the traditional data pump available for full schema or database migration, and then we have the export and import model procedures in the DBMS data mining package, which are a very convenient interface for selected model import using the data pump in the background. Now let's take a look at the serialized model approach next. So the serialized model format was designed as a lightweight approach to support scoring. Export SIR model exports a single model to a serialized blob so it can be imported and then scored in a separate database instance or to OML services. Import SIR model takes that serialized blob and then creates that model in the target database. In contrast to export SIR model does not retain model detail views, and it only retains the model contents and the metadata required for scoring. So for example, K-means clustering models need the partition names and cluster IDs for scoring. So this information and other model data is then retained to support the scoring. And as a result, the serialized model is more compact, up to 300 times smaller, and transfers about 300 times faster to the target environment than dump files produced by export model. So use export model in scenarios when the model details are desirable, and then export SIR model when they are not needed, such as for scoring. It's also important to note here that the serialized model export supports only models that produce scores. So specifically, it does not support attribute importance, association rules, or exponential smoothing. So to recap, use export model to export these models and scenarios when full model details are required. So now we have an example of exporting a serialized model from a source environment to a target environment. The target schema can reside in the database or another database. So on the left, an OML user exports a model with the same GLM model to a serialized blob with the name glmmod.mod in the data pump directory. Again, any directory that is defined as a directory in SQL by the user and accessible by the user will work. So on the right, the serialized model is then saved to the data pump directory in the target environment by the target user. It is then saved in a temporary table and then imported into the target schema. It's important to note here that schema and table space mapping is not required for serialized models, as it was with import model, because this information is not carried with the serialized model. However, there is some handling for serialized blob that is required, such as the custom write serialized model procedure shown on the left. We'll go more into this detail about this in the demo that will be hosted by Sherry in a little. In addition, when using Autonomous Database, you'll use the DBMS cloud procedure to move models between the database and object storage. Also note here that export SIR model and import SIR model can only be used to export and import individual models. So in summary, there are 3 different sets of APIs for model migration, and all of these APIs are available for Autonomous Database and Oracle Database on-premises and DBCS. Sherry will show examples of the export model and export SIR models in the demo coming up. The traditional data pump, ideal for full database or schema migration, can be used again with a single database or a split development and production architecture. DBMS data mining provides the 2 sets of procedures for model migration. Export and import model migrates selected models to and from a dump file. It retains all the model details views from the model exploration, and it can be used with a single database, a split dev and production architecture, or with split workloads where you build and test in a development database, test the solution in a test database, and then score in a batch in a production database. The second option within this package is the export and import SIR model, which migrates models to and from a serialized blob. It is far more compact than the models produced by any other method and is ideal for scoring and inference, where only the model content and specific metadata are needed for scoring are retained. And in addition to that, the other deployment architectures we discussed, it also supports deployment to OML services on Autonomous Database. All of these options provide convenient, easy-to-use tools for model migration that are native to the database environment. And it's important to notice that serialized models will support all the typical deployment architectures, and it really should be used unless you want the full model detail views. It's a compact representation, makes it much faster for you to move between databases, and the API is simple, robust, and very easy to use. For more details on these various deployment architectures that we see, you can check out Mark's blog post on the top architectures for enterprise machine learning, and that will also be linked at the end of this session. So now let's dive into our first architecture here. So let's look at a few deployment architectures. So here we have a split environment where we build and test in one database and then score in a production database. Scoring can be done in Autonomous Database, Oracle Database, or OML services, which we'll show in the next slide. The DBMS data mining package has support for both the data pump API export and import model, and the export and import of serialized models. In each case, the model is copied from development to production for scoring by the target user, although database links can be used with the export model if desired. Again, the serialized model format is more compact because it only contains model-specific content and metadata for the scoring. It transfers more quickly between environments, and we recommend using it unless you want all the model details views for exploration preserved. In this following architecture slide, this is an example of a real-time scoring architecture where we build and test a model in either Autonomous Database or Oracle Database and then deploy it to OML services for scoring. In this case, we need the model in the serialized format. So OML services provides the REST endpoints hosted on Autonomous Database. And then these endpoints can allow you to store OML models and creating scoring endpoints. The REST API for OML services supports both OML models and ONNX model formats, as well as enables cognitive text functionality. So now, with that said, I'm going to turn it over to Sherry for the demo portion of this presentation. Sherry, off to you.
Thank you, Ethan. Okay, so this is OML Notebooks. And today it's a Zeppelin-based interface, and it has interpreters for SQL, PL SQL, Markdown, R, and Python. And we're going to start with Autonomous Database, getting into exporting models here. There are a few prerequisites that Ethan had mentioned. The DBMS cloud package allows us to interact with other cloud services. And in this case, specifically object storage, where we'll be moving models to and from object storage so we can export and import them into Autonomous Database. So for the DBMS cloud package, there are a few things. One of the things that we need to do is create a cloud credential to allow us to access our object storage from the notebook. And you can have a bucket. Your object storage bucket can be public or private, but even if it's a public bucket, you still need a credential to write data to the public bucket. And in this example, we're using a public bucket. If you had a private bucket, you would need the credential to read and write from that. And after the credential, you would create these pre-authenticated requests. And these can be defined, created at the bucket level or the object level. We're using object level requests. And for each of our models, we create this pre-authenticated request, which is this URL. And this is what it looks like. And it basically has this resource identifier is what it is to a specific object. So in this case, this is a pre-authenticated request to a CSV file, iris.csv, but we'll be using those for our models as well. And then once you have that pre-authenticated request, you can use wget or curl to download that, like to your Linux or Mac system, or to your Windows machine if you're going to be using Windows. So then the next thing that you need to do is create a directory for persisting these objects. And in our examples, we're using the data pump directory here because it's just very convenient, but you will need to get read and write access to that data pump directory for your OML user, and then execute privileges on DBMS Cloud. So those are the additional requirements for Autonomous Database. You don't need any of those requirements for Oracle Database to interact with object storage. You can just use the pre-authenticated request that somebody else created to download the models. Okay, so by starting, we're just creating a database table called cars using the empty cars data in R, and the table is called cars. And then we're going to drop and build a model, GLM model 1, using the create model 2 procedure. And the target column is miles per gallon. And now that I've created that, model is persistent in the database, and I'm going to view the model in the database. I can query the model using the user mining models view, and then I can export the model. So the first export that I'm doing here is a serialized model. So I'm going to export this model to a serialized blob, which is stored as a B file in the data pump directory. And then I'm going to send it to object storage. I'm doing both of those things in this script paragraph. And the script paragraph is actually a PL SQL in OML notebooks. So the model name is GLM Model 1. I have already created this pre-authenticated request to send this model to the serialized blob to object storage. So I've done that in advance. And then what I do is I export the model. I save it to a blob and then export it to the data pump directory. And here's my helper function, write serialized model, that helps me interact with the data pump directory. And then I use the put object procedure to send that serialized blob to object storage. So it's there now, and the name is GLM model1.mod, and I can download that if I want to and import it into my Oracle database, or I can also import it into another autonomous database. I can actually re-import it into this database at some point if I would like to as well. And if I want to export a model as a dump file to the data pump directory, I can use a similar approach, except instead of using export ser model, I'm using export model. So again, the model name is GLM Model 1, and it's going to, the dump file is going to have a DMP extension, and I first save that to the data pump directory, and using export model. And here is how I use this model filter to specify my model name. And as Ethan had mentioned, I can put multiple model names in there, or I can filter on the algorithm type. And then I send the dump file to object storage using the put object procedure. And the model is saved as GLM model 1.dump, and it's both in the data pump directory and object storage now. Okay, so similar to import models on Autonomous Database, it's important to remember that the source of the database could be another Autonomous Database, or it could be Oracle database on premises. So here, I'm going to import a serialized model that's already saved in object storage. I have uploaded that to my object storage bucket, or I have sent it there from another Autonomous Database. And I have a pre-authenticated request, which we're putting in this location URI parameter for that object that allows me to, read that in here. And then I define the model name that I want to have it imported as. And then I'm saving that blob model to a variable first, and then importing it using import ser model. So the serialized model name and object storage again was GLM model 1.mod, and then I'm saving it back to the database with the name GLM model 1. And of course, I'm dropping the model first. If that model already exists in the database, you wouldn't be able to re-import a model with the same name. You would get an error that there was a naming conflict. And then I can query the model description, so I can see the model name, GLM Model 1. It's a regression model using our GLM algorithm and when it was created. And also query the model settings. Some of these settings were provided on when we built the model, and others are model defaults. And then I can score that model that I just imported. So I'm showing the first 5 rows here, but you can see that I have the predicted miles per gallon versus the actual, and then we have a case ID here for row identification. And then to import a model from a dump file on object storage, very similar. I have a pre-authenticated request. The only thing that's different here is that I'm using import model instead of import ser model. So I'm importing the model from the dump file, and I will, when that is imported, then I will have the all of the model detail views, and I can score that model as well. I think you'll notice here that this took 48 seconds to import, whereas the serialized model was like 2 seconds. So serialized model import is much faster. Okay, so now let's go to Oracle database. Okay, so here I have, this is SQL Developer, and I'm connected to an on-premises Oracle database here. And I have, first I can, I'm dropping and building the exact same model that I had in Autonomous Database. It's the same generalized linear model using create model 2. And here I'm defining a directory as home Oracle. I could use the data pump directory if I wanted to, but I'm just going to use my home directory. And then I'm first going to export the model using the data pump implementation. So again, here's the model filter. I've defined this directory in SQL, and I have, obviously, since it's my home directory, I have access to write to that directory. So I export the model, I provide the file name, and then I can just navigate to that directory, and the model will be there. And then I can then import that into another Oracle database or another Autonomous database as well. And then to export the serialized model, there's a little bit of additional blob handling that has to happen. These blobs need to either be saved in a variable or a table before they can be imported to the database, which is simple enough. So we're doing that. We're creating a table called blob model and saving that serialized model in that table and a column in the table, and then importing it using, exporting it using export ser model. And I write it to my directory, and the model will be there with the name glm model1.mod. And it is much smaller, much more compact representation, up to, as Ethan mentioned, 300 times. Then to import these models back into Oracle database, of course, I drop the model if it already exists, and then I can use import model and specify the dump file name and the place, the directory where this dump file resides. And then I can just view all of the model views, like we said, with the dump file import and export. The model detail views are preserved. So the model detail views, they start with the DM $. VA is the name of the view. So those are the GLM regression row diagnostics, and then followed by the model name. So that's what they look like. And then you can query each one of those to see, get more information. And then to import a serialized model, again, I'm creating a table to temporarily store that model. It's called my model, and then saving that model to a column in that table, and then importing it using import ser model. And then I can verify that the model was imported and look at the model settings if I want to. So let's just run that. And again, some of these were provided during the model build, others are defaults, and then I can do this scoring. And you can see the predicted miles per gallon versus the actuals. And all of these examples will be available to you after the session. The last thing that I wanted to show you was that these serialized models can be deployed to OML services. So this is Postman, and it's a REST client. And you could use a curl instead if you wanted to. But and OML services is available on Autonomous Database. And one thing that's important to note is that the model that you deploy for scoring in OML services, it can be built on Autonomous Database or Oracle Database. It's just that OML services itself is only available on Autonomous Database. So the first thing that I need to do is get a token. And when I get this token, I have this environment here, and this environment contains my OML username and password and my tenancy information. So I can connect to the this token service. It's this endpoint, and get this token back. And here's the token, and it's going to allow me to interact with the other REST endpoints OML REST endpoints for an hour, or I can refresh the token before it expires or get a new one. And so the first thing that you have to do is actually store this regression model in the OML services repository. And I have this saved locally, the serialized model. So I have it saved, and then I just basically navigate to that from here. I have a version. This is the second version of that model, and it's shared. I have shared it with the others in my database so that they can run scoring for this model as well. And then I have to create a scoring endpoint, which returns this model ID. And with that model ID, I can use that then to score the regression model. I have a pointer to this model, and I can score the regression model. So let's do that. This is a single input record. And so we get, one scoring result, but you can also do mini batches of records, or OML Services supports batch scoring requests as well. We did a session about that last month. And anyway, you can remove you can delete the model from OML Services, but first you would need to remove that scoring endpoint. And that's all I wanted to show you today. Back to you, Ethan.
All right. Thank you, Sherry. So moving on here, we have another poll, I believe. So
Yes.
Mark, if you want to take it away.
Yeah, thanks, Ethan. And so for our second poll, how has this session helped you with your understanding of the OML model export and import? Were you new to this topic, but now have a good understanding of how to apply this capability? Are you more confident, but still have some questions about how to best use it? Do you feel confident to start using this in your next project? Or you are already using this capability, and this session reinforced or enhanced your understanding? So it looks like we've got a 79–80% are saying it's new to this topic, but now have a good understanding of how to work with it. Another 5% are confident and still have some questions. 21% feel confident to start using export and import. That's great to hear. And we have some that were already familiar with this capability, another 5%, and this just reinforced it or enhanced their understanding. Well, thank you very much for that feedback. And back to you, Ethan.
Awesome. Thank you, Mark. All right, so we are here at wrapping up the presentation. For more information, we've linked a few helpful links here. One to the OML webpage, to another one to the blog that we were talking about that Mark wrote around the top 5 deployment architectures. We have a link as well to the OML GitHub repository, as well as a link to the OML office hours that occurs, and a link to the official OML documentation.
And for Q&A, we did have one question that came in. Sherry, maybe you'd like to tackle this live as well. Is model migration currently available only with OML for SQL, or can it also be done with OML for Pi and OML for R?
Yeah, that's a good question. So today we do have an API for exporting serialized models with OML for Pi, and import serialized models will be coming in the future for OML for Pi and OML for R. And OML for R will also support exporting serialized models, but there aren't direct APIs. You can use the ori.exec interface with OML for R to export a dump file or import a dump file, and you can do the same thing with CX Oracle on the Python side, but there aren't direct APIs. The only one that exists today is for exporting serialized models from Python.
Thank you, Sherry. And also just a basic question of what is a serialized model?
Right. So the serialized model is saved as a blob in a B file that can be then imported back into Oracle database as a column, if you just wanted a B file type. So it's basically a data type for Oracle that contains serialized contents.
All right. Well, thanks again, Sherry. And with that brings our session to a close. And thank you both, Ethan and Sherry, for a very interesting and important topic on Oracle machine learning. So until next time, take care, everyone.